Game Theory Fundamentals, Episode 4. Dominant versus Dominated Strategies. In the previous episode, we learned how to represent games using the strategic and extensive form. In this episode, we will explore the dominant and dominated strategies, and how they can help us find the optimal actions and outcomes in strategic situations using the iterated deletion method. That will lead us into the Nash Equilibrium. This is a very important episode, so watch it till the end. A dominant strategy is a strategy that leads to better outcomes, the choices that always outshine the others, regardless of what the other player does. For example, suppose you and your friend are playing a game where you can either cooperate or defect, and they can also choose to cooperate or defect. If you both cooperate, in this matrix you can see the overlapped cell is the outcome for both players, so you each get 3 points. If you both defect, you each get 1 point. If one cooperates and the other defects, the cooperator gets 0 points and the defector gets 5 points. In this game, defecting is a strictly dominant strategy for both players. Why? Let's see from your perspective. If the other player chooses to cooperate, you will be better off if you choose to defect, since you'll get 5 instead of 3. Let's mark our preferred payoff with an asterisk symbol. And when they choose to defect, you'll also get better payoff when you choose to defect instead of cooperating. Hence your dominant strategy is to defect, no matter what the other player does. In this case, defect is your strictly dominant strategy. For it to be called a strictly dominant strategy, all payoffs of the chosen strategy must be higher than the other payoffs. Just like in this example. If any of them are equal, then it will be called a weakly dominant strategy. Let's say instead of 1, you will get 0 as payoff if you defect, while the other player defects. Then defect is a weakly dominant strategy. Cooperating, on the other hand, is a strictly dominated strategy for both players, because it always gives them a lower payoff than defecting, no matter what the other player does. Let's see it from the other player's perspective. If they think you will cooperate, and they decide to cooperate as well, then they will get 3 instead of 5. The same goes for when they think you will defect, they will be worse off with cooperating, since they will get 0 instead of 1. So no matter what you do, they will get worse payoff by cooperating. So cooperating is their strictly dominated strategy. And if any of the payoffs are not lower, but equal, then it is the weakly dominated strategy. The implications of dominant and dominated strategies are very important for finding the best actions and predicting the behavior of rational players. If a player has a dominant strategy, then they will always play it, regardless of what the other players do. If a player has a dominated strategy, then they will never play it, because there is always a better alternative. Therefore, we can use the concept of strategic dominance to eliminate the strategies that are not optimal for each player, and find the strategies that are optimal for each player. One method to do this is called the iterated deletion of dominated strategies. This method involves iteratively removing dominated strategies from the game, until we are left with only the optimal strategies. There are 2 versions of this method. The first version involves only eliminating strictly dominated strategies. The second version involves eliminating both strictly and weakly dominated strategies. The first version is preferred because it preserves all the Nash equilibria of the game. A Nash equilibrium is a combination of strategies where no player can benefit by deviating, given the actions of the other players. Let's see an example of how to use the iterated deletion of dominated strategies method to solve a game. Suppose you and your friend are playing a game where you can either choose A or B, and your friend can either choose X or Y. The payoffs are shown in the following matrix. In this game, there are no strictly dominant or dominated strategies for either player. However, there are weakly dominant and dominated strategies. For you, choosing A is weakly dominated because it gives you at most the same payoff as choosing B, and strictly lower if they choose X. For them, choosing X is weakly dominated because it gives them at most the same payoff as choosing Y, and strictly lower if you choose A. Therefore, we can eliminate all the weakly dominated strategies for each player and get a smaller game. In this game, there is only one strategy for each player, and this strategy set is a Nash equilibrium. As you can see, the concept of strategic dominance can help us find the best actions and outcomes in strategic situations. However, not all games have dominant or dominated strategies, and sometimes there may be more than one Nash equilibrium. In those cases, we need to use other methods and concepts to analyze the games, such as best responses, mixed strategies, and subgame perfection. We will cover these topics in the next episode. Thank you for watching, and see you soon.